In this video, we're going to talk about vertex form of a quadratic function. Now, sometimes you might see in a textbook or in some courses, they call it standard form of a quadratic function. But typically, we'll see it as vertex form. So keep in mind that when we talk about standard form, we have to be careful if we're talking about standard form of a polynomial, just in general, or of a specific quadratic function. So we're going to look at how can we find these key points from vertex form. So how it opens is given. X and y intercepts will be a little lengthy in finding those. And then these other three are sort of given based on what we see from our equation. So how it opens, just like any other form for a quadratic function, depends on this a value, the sign of the a value. If it's positive, it opens up. If it's negative, it opens down. So whatever that's coefficient here is in front of our parentheses, that tells us if it opens up or down. Y-intercept, we know x is always equal to 0 in that case, so we just go ahead and substitute that in and evaluate f of 0 given our function. In this case, remember order of operations, or PEMDAS, so we do parentheses first, we get -1 in there, square it, we get 1, times 3 is 3, plus 6 is 9, so our y-intercept is 9. Our x-intercept, this is probably the more challenging part of our graph when we're dealing with vertex form. So we know that y equals 0 for all x-intercepts, but we could have 0, 1, or 2 x-intercepts for a quadratic function, or solutions, you may refer to it as. So when we solve for x, we don't really know what we're going to find. So y is equal to 0, or since it's in function notation, we say f of x equals to 0, so we substitute 0 in for f of x right here, and then we just solve for x. So again, remember opposite order of operations, or opposite PEMDAS when we're solving. So we go ahead and we end up getting to this point where we have to take square root. We have to remember to do plus or minus when we take square root of a number. And that will typically give us 2 solutions here, or 2 x-intercepts. Remember, these could also be referred to as roots or zeros. The vertex, this is what's nice about vertex form, is because it's called vertex form, we know exactly what that vertex is. It's the h and k value in this equation. So remember that this is minus the h or x value of our vertex. So if we've got this example here, x minus 1, 1 is the x value in our vertex, and then whatever this k value is here is the exact same in our vertex for the y value. The maximum and minimum, that always depends on our vertex. So again, since we know, and it also depends on if it opens up or down. So we can see both of those. We don't have to solve anything to find those. So in this example that we just found, the vertex of 1, -8, our maximum or minimum is going to be -8, right? Because in a quadratic, we don't have a max or min for the x value. It goes from -infinity to infinity. So we're either going to go up from this point or down. And since the a value is positive, our parabola opens up. So that means the vertex is going to be at the bottom of our parabola. So this is a minimum value here. So we can circle this and say minimum since it opens up. And then last step, domain and range. Again, this depends on what that vertex and max or min represents, because our domain is all real numbers, and our range depends on if we have a max or min and what that value is. So in this same example, We've got this vertex at 1, -8. Since it opens up, we know that we had that minimum here at 1, -8. So our range goes from -8 up to positive infinity. We'll go over more examples in other videos for some of these examples of solving for x or y intercepts, for example, using vertex form of an equation.